Find the vector, parametric, and symmetric forms of the line with direction vector v equals -6, 12, 5 that goes through the point P, 13, 2, -7. So first, if we have a line through the origin, this is the origin, then there's some direction vector v associated with that line. So let's say v is ABC. Then the equation of this line is xyz, a point on the line in vector form, equals t times v, or t times ABC, where t is a real number, minus infinity to infinity. Now, if our line does not go through the origin, then we take this TV and we have to add a point to it in vector form to translate the line to make it go through this point. So our line, so if you have a line that goes through a point, let's say we have some random point x0, y0, z0 in R3, then we have our direction vector v, which is still ABC. So instead of the line going through the origin, it goes through this point, and this is ABC. So then we want this line right here, pretend that's a line. Then the equation of that line is xyz equals, and then we take TV and we add the coordinates of this point to it, and we have to do that in vector form, x0, y0, z0 plus TV, or x0, y0, z0 plus t times ABC. This is what's called the vector form of the line. And the parametric and symmetric forms can easily be determined from the vector form. So first we'll start with the vector form. So for our line, we just substitute these details in. The point is the x0, y0, z0, and the vector is ABC. So our line in vector form is xyz equals 13 to -7 plus t times vector v, which is -6, 12, 5. So there's the vector form. The parametric form involves simply combining the terms on the right side and then equating the components. So the first component here is x. We'll call that x of t. X depends on t. X of t equals, and if you combine these, you distribute to you distribute to t, you get -6t, and then add 13. So -6t plus 13, or 13 minus 6t. So that's the parametric form for the x component of the line. Then we have to do the same thing with the y and the z components. Y of t. So what's y of t? Y is in the middle, so it's going to be y0, where is it? Y0 plus t times b. So 2 plus t times 12, 12t, or 12t plus 2. And for the z, the third component, z is equal to -7 plus 5t, -7 plus 5t, or we could write that as 5t minus 7. So this is the parametric form. Now, to make the symmetric form, we will simply take these equations write the first equation with just x equals, the second equation with y equals, and the third equation with z equals, and solve each of these three equations for t. So the first equation, x equals 13 minus 6t, if you solve for t, t is x minus 13 over negative 6. Or we can write this as moving the negative upstairs, negative x plus 3 over 3 minus x over, sorry, this is t equals 3 minus x over 6. This equation right here, move the negative upstairs, negative x plus 3, 3 minus x. So t equals 3 minus x over 6. And we do the same thing for the y equation. So what was y equal to? Y is equal to 12t plus 2. And that tells us that t is equal to y minus 2 over 12. And the third equation, z equals 5t minus 7, gives us that t is equal to z plus 7 over 5. So now we have three different expressions for t. T is equal to this, t is equal to that, and t is equal to the other. So the symmetric form is to equate these fractions. 3 minus x over 6 equals y minus 2 over 12 equals z plus 7